Hello everyone, and welcome to the implementation of a bubble sort lecture. So as a quick reminder, the bubble sort makes multiple passes through a list. It compares adjacent items and exchanges those that are out of order. Each pass through the list places the next largest value in its proper place. So in essence, each item is bubbling up to the location where it belongs. So as always, here's the notebook. You have resources for review, including visualizations, and we're going to go ahead and program out our own implementation in Python and explain as we go along. So go ahead and open up a new Jupyter notebook. Let's go ahead and zoom in here real quick, and let's get started. So first thing we're going to do is go ahead and start writing out our function. In this case, we'll just call it bubble underscore sort, and we'll take in an array ARR. Now again, in Python, this is just going to be a normal list, but we'll treat it with the term ARR just so we can generalize it to an array. So what we're going to do is say for n in range, and this is where it's going to get a bit tricky, but we're basically going to arrange it backwards, and I'll show you what I mean by that in just a second. We're going to say length r minus 1 to 0 in steps of -1. So let me go ahead and show you what that looks like. I'm going to go ahead and say pass here. And then let's go ahead and say r is just 1, 2, 3, 4, 5. And if I just go ahead and print this out, you'll basically arrange everything backwards except for the very last element, since we're going from -1. So just keep that in mind as we go along, what this is actually going to do. If you're using Python 3, in order to see this result, you would have had to have called list on this, since range is just a generator in Python 3. Okay, so let's go ahead and keep on moving. So the next thing we're going to do is then say for k in range of n. So as we go along with that list, remember we had that 1, 2, 3, 4, 5. In this case, we're going to go all the way from k0 to n. So to understand this logic, what we're going to say is if the array at that value point, basically that index, is greater than k plus 1, let me fix those brackets there, k plus 1. So we're basically checking here if we're going to come to a point where we need a switch. So I'm going to say make a temporary variable equal to r of that k, that index, and then say r of k is equal to r of k plus 1, and then say r of k plus 1 is equal to that temporary variable. And that's really all there is to it for this implementation of the bubble sort. Okay, so let's go ahead and test out our solution, make sure it runs well, and then we'll break down step by step one more time what we're doing. So I'm going to go ahead and say create an array, and we'll say 5, say 3, 7, and 2. So that's already unsorted. We're going to call bubble sort on that array, that list, and then print out that array again. Okay, perfect. So it was sorted. Notice that I don't have a return function on a return keyword on this function, so it didn't actually automatically return it. If you wanted to, you could have added, in line with this for loop, return ARR in order to not have to redo and print that array. Okay, so let's go ahead and go one more time what's going on in this function. So I'm saying for n in range, and remember we are actually just saying everything in reverse order. So let's go ahead and show that one more time. So range of length of ARR -1, 0, -1. So if this is our example array, what we should see out is 3, 2, 1. So that's going to help us see what actual index we should be doing when we come to the k. So I'm going to go ahead and say print k and print n here. So if we run this on a very short array, these print statements might help us visualize what's actually happening. So if I say bubble sort r, you can go ahead and see the print statements and the actual arrays we're checking at that point in time. So I'm going to go ahead and say this is the n, comma, and then here I'm going to say this is the k index check, comma. All right, so you notice what's happening here is at every n, we're going to go ahead and do index checks from 0 up to that n. And this is where the bubbling is occurring. And remember from the diagram, we only have to bubble less and less as we continue on, depending on which side we're going from, and this side from the left. So go ahead and check this out. Definitely use print statements in case you're still confused about the steps themselves. But all we're doing here is saying from n at 3, since we have a length of 4, go ahead and do index checks at 0, 1, and 2. Once we've done all the way up to n, we'll go ahead and do to n equals 2, then we'll do 0 and 1, and then keep subtracting. And as far as the actual index checks, what's going on, we're just checking at the 2 adjacent elements in this array if one's greater than the other. If it is, we just go ahead and do a swap with these 3 lines here. We're using a temporary variable so we don't accidentally overwrite anything in that list or array. Okay, so that's it for the implementation of bubble sort. Hopefully you can see it's quite simple. As far as this line and this line, different methods may operate these 2 lines differently. So depending if you're running from the right of the list or the left of the list, you may bubble up in a different manner. But as far as our implementation, this actually makes sense. And this comparison is going to be very, very similar no matter which way you go. All right. Thanks, everyone, and I'll see you at the next lecture.